one of the most beloved educators here at Plaksha. A brief intro about Alex. He's a world-class expert on emerging technology and business applications, specializing primarily in the area of AI, data science, and blockchain. He's a faculty here at Plaksha and also a founder and CEO of Predli, a global emerging technology advisory firm. He's the AI and blockchain director of Learn to Launch at UC Berkeley Center of Entrepreneurship and Technology. Among his various achievements, he has also been awarded with the Amazon's prestigious Innovation Fellowship for 2018-19. He has been on the founding team of multiple companies and has a successful track record of consulting Fortune 500 companies. Without taking any further time, I'll hand it over to him. And before we do that, I'd just like to add this personal note. I have had the privilege as a part of the Plaksha Tech Leaders cohort to be taught by Alex. And had it not been for him, we would still have been dabbling in the unknown. We would still have been not able to imagine. We still had not been able to imagine the wide possibilities of AI and ML, and still had a very narrow point of view. So I just like all of us here, I'm really looking forward to this session. Handing it over to you, Alex.
Thank you so much, Ankit, and that makes me very happy to hear your very kind words. Now, welcome everyone to this evening session. If you're in India or whatever else time zone you're in, good morning, happy lunch, happy Monday at least, I guess. Now, I'm gonna go ahead and get started because the presentation that I've prepared today can take approximately an hour to cover. I'm gonna do it a little bit more rapidly so that we have time for some Q&A towards the end. And I think that I heard you can write your questions in the chat throughout the presentation now. I'm gonna try to contain the Q&A for the end of the session now. But if you have some urgent questions that you wanna ask throughout, and if you want me to pause or maybe double click on a certain topic, feel free to write that in the chat as well, and we will see what we can do. So first of all, I'm gonna share my screen. Now, Ankit, are you able to see my screen?
Yes, Alex, I can.
That is wonderful. Now, the presentation that I prepared for you today is that I'm going to talk about state-of-the-art AI applications. In order to do that, we're going to cover three main application areas of artificial intelligence. So we're going to talk about computer vision, generative algorithms, and we're going to talk about natural language processing. The 45-minute journey that we have in front of us looks like this. So I had actually prepared an introduction slide of myself. I think that Ankit actually covered that really well now when he introduced me. So I won't spend more than 2 seconds on that part. Then we're gonna jump into one part of the presentation that I call demystifying artificial intelligence. I would like to talk about the current hype wave of AI, where we are today and where I see the trajectory leading into the future, and also go over a couple of basic terminology so that all of us are on the same page. Then last but not least, the bulk of the presentation is going to be around state-of-the-art AI applications. Now, some of you among the participants, I actually looked at the list when you were joining. You are either former students of mine or you are in the current cohort at Plaksha, etc. I think that you might have seen some of the material that I'm going to cover today. What is really important is that what I'm going to show you now doesn't require any type of background in programming, mathematics, in data science. It will be accessible to everyone. So I'm going to keep it very high level and discuss the topics from a conceptual level. You don't need any type of degree or any type of background to understand and follow what I'm going to present today. Now with that, to quickly say hi from my side, my name is Alexander Fred-Ojala. I'm a faculty member and an instructor at UC Berkeley, currently the technical director of the Learn to Launch program. I'm also a co-creator of the DataX course and the Data Lab at the Center for Entrepreneurship and Technology that has a collaboration with Plaksha. As Ankit said, I have a little bit of an entrepreneurial journey behind me. I'm currently a co-founder of 2 companies, and I have been running 2 other companies in the past, one in the Silicon Valley region and one in southern Sweden. I'm from Sweden, if you notice a little bit of an accent. Yeah, so I'm not native English speaker, but I think that's going to be fine. I've practiced for many years now. I've been at Berkeley since 2015, I can also tell you. And then my greatest award, I guess, just as Ankit said, is the Amazon Alexa Innovation Fellowship that I received as one of 10 faculty members globally for the work that we did in the data lab around natural language processing. So with that, let's jump into the presentation. And the first thing that I want to cover is AI up until today. So what is all the hype about, and why are everyone talking about AI? And one of the first things that I would like to note is that many people today call artificial intelligence the fourth industrial revolution. So during historical times, up until today, we have had three major technological shifts in societies. And the first one started with the Industrial Revolution in the 1800s. And that was when, for example, countries like England or the Great Britain came up with the innovation of the steam engine. Now, for those countries, the technology steam engine became a competitive advantage and made those countries very prosperous during this time. And if we move forward to the 1990s, then we can also see that the second industrial revolution is actually the introduction of robots in manufacturing facilities and in production pipelines. So both of these technological shifts, according to economists and economy professors, that led to an increase in labor productivity for the societies that adopted these technologies with 0.3% per year and 0.4% per year. That might seem to be a low number, but it's actually very significant. And only if you go back in history and look at what happened with the UK when they actually went through the Industrial Revolution, you can see what kind of impact an innovation like this could have. Now, again, in modern times, the third industrial revolution is the rollout of personal computers, of IT equipment, and the rollout of the internet. Now, this had an even more or greater impact on labor productivity. So this is 0.6% per year. And now if we turn our eyes to AI instead, we can see that we are just starting to notice the impact of artificial intelligence as a technology in societies. But the same economy professors and researchers, they estimate that AI's impact in labor productivity increase is going to be 1.2% per year, which is remarkable. And in order to summarize this slide, then we can say that innovation and technology like steam engines or the robotization of production lines, what that led us to as humans is that now we can exceed our ability when it comes to physical strength. We don't need to rely on our own bodies anymore, but now we have machines that carry out physical work for us. Now, if we look at the rollout of the internet, that enabled us to actually share information globally in real time and also store all information. So we don't have to rely on our own memory anymore, but we can have information in a digital format that we can send all over the world in an instant. For AI now, what we will be able to do and what we already can see is that we as humans now, we can exceed our cognitive ability. We don't have to rely on our own brain power anymore in order to make predictions or make smart decisions. But instead, we can have models and algorithms and systems that makes those decisions for us and that analyze more data than a single human can do, or even all of humanity, the global population, what we can crunch. And that's going to have a major impact, both moving into the future, and it already has that today. And one graph that I love to look at is the one that you can see on the slide here now. So this shows the gross domestic product for the world all the way back since year 0. And what you can see here now is that all of these prices have been adjusted according to inflation. All of the prices are in 2011 numbers. You can see that not a lot happened with this graph up until the 1500s, and that's the Renaissance period. And then we have the 1800s over here, and then we start to get this like exponential trend with this graph. Now, this graph doesn't cover the impact of AI, but I can promise you that it's going to be an even steeper hockey stick now when we see these very powerful algorithms and models being deployed and used in society. So in order to truly understand the impact of artificial intelligence and these very powerful applications, then it's important to also answer potentially the most basic question there is, and that is, what is artificial intelligence? Now, every non-technical AI presentation usually starts with a quote like the one that you can see on the slide here. This specific one comes from Sundar Pichai, and he has said, so Sundar Pichai is the CEO of Google and Alphabet, that all of you know. So he has said that AI is one of the most important things that humanity is working on, and he even thinks that it's more profound than electricity or fire. Now, it is a cliche today to say that AI is more important than electricity, fire, the airplane, the automobile, that it's the most powerful technology that we have created. And also people will claim that data is the new gold or data is the new oil, that basically data is the most valuable asset that we have in a society today. So I'm not presenting something that is new here. However, what I want to convey is that in every cliche, baked into it is a lot of truth. So the reason why very smart people keep on saying this is because AI is going to be one of the most revolutionizing technological shifts that we have ever experienced. So in order to define what AI really is, I think that first of all, we need to define what human intelligence is. And now there is no generally accepted definition of what human intelligence is. It's not that you can look it up in a dictionary or in a lexicon. Scholars, neuroscientists, researchers, philosophers, they have debated this for centuries or even millennia. I'm not going to jump into that debate, but I will show you a couple of bullet points that I think relates to human intelligence. And that could be our ability to define problems and also solve those problems, that we can set goals for ourselves as humans and also achieve those goals. We can analyze and reason about situations, about the past, the present, and the future. We can also communicate with one another. We can collaborate in accomplishing goals and tasks, and we can influence one another into making smarter decisions. This is what has led to the creation of societies and civilization. Now, last but not least, I would also like to claim that human intelligence relates to our ability to be conscious, that we are aware of our own existence, and also that we can feel emotions, that we have something that we might call an intuition, and also that we have an imagination and that we can dream. Now, if we turn to the right-hand side of the slide, then you can see that we're now going to define artificial intelligence. And AI also doesn't have one true definition. A lot of smart people have debated on what the definition of AI is. You're going to see my favorite definition of AI here now, and that is the ability for algorithms, models, systems, and machines to be able to simulate and even enhance aspects of human intelligence or intelligence overall. And what I can tell you is that AI today is really good at solving problems and achieving goals in well-defined contexts. It can also analyze and reason about different situations to some extent. It can communicate with other algorithms in order to make hybrid decisions and find synergies. However, AI systems and models are far from being conscious. They don't feel any emotions, at least in the sense of human emotions. And I don't think we're going to see self-aware AI systems or algorithms in many decades, but we will see. So that is something that truly distinguishes us as humans, at least for now. Another thing that I want to highlight and emphasize is that AI is not something that is new. It has actually been around for a very, very long time. One can even claim that the great mathematician Gauss, when he, during the late 1700s, was solving the ordinary least squares problem and fitting linear regression models, then he was doing something that we today call AI, because linear regression is maybe the simplest machine learning algorithm, and machine learning is a subpart of artificial intelligence. However, if we fast forward to modern times, then we can see that we have had 3 distinct AI hype waves, and we are currently in the 3rd one. The first one started in the 50s, and that is when we saw the theoretical foundation and the publication of research papers around how the perceptron worked and even how neural networks worked. A lot of people already back then had a lot of hope around what cognitive machines could do for humanity. However, when we started taking some of these theories and put them into practice so that they were going to solve real problems, their functionalities were very limited. So we entered the first AI winter in the 70s. Then again, during the 80s and early 90s, there was a lot of buzz and hype around machine learning and symbolic AI. So during this time was actually the point in time when the first email spam filters using machine learning algorithms were implemented. We even had convolutional neural networks that would analyze handwritten digits in order to sort packages and envelopes at post offices. However, many of these systems, for example, symbolic AI that was going to map human language, when they were put into practice and when they were battle tested in real life and in the real world, they didn't live up to their promises. So during the early 2000s, we entered the second AI winter. And now, since the early 2010s, or especially since 2012, we are in the third AI hype wave. And I would like to claim that this is AI's true renaissance period. And this is the deep learning revolution. And this is not going to lead to an AI winter anymore. AI is here to stay, and it's already delivering so much value that we won't enter another period where we start to doubt this technology. The main reason for that, and what is different today in comparison to the 2 earlier AI hype waves, is that today we actually have a lot of data available so that we can train very powerful algorithms and models. As an example, in only 48 hours or 2 days, we produce more data right now than what humanity did in its entire history up until the year 2003. So no wonder that we actually entered an AI winter in the early 2000s if we today produce more data in 2 days than what we did in our entire history up until the year 2003. So we have lots of data that we can use in order to train these powerful algorithms and models. In order to do that, we also need very powerful computers. And we are very lucky because the development of computers and computational power has closely followed what is being called Moore's law. And that states that every 18 months, the processing power of a computer is going to double. Then you get this exponential trend over years, and the actual progress and the capabilities of computers have closely followed Moore's law. So today we have powerful CPUs and GPUs, TPUs, and even custom-made processors and chips and hardware that can train these very powerful algorithms. The third factor that is different today is that almost on a weekly basis, as a person who is an active researcher in this space and who monitors and follows the space very closely, I feel that I find a new methodology, a new implementation approach, a new application area related to the AI space in a research paper or as an emerging area where I almost have to buckle up in order to contain my excitement. So we see a lot of algorithmic advancements and a lot of new approaches being released at least on a weekly basis. The fourth factor is that we also have a broad public interest around AI as a technology. Only this webinar that is being hosted today speaks to that fact. The fact that many countries are investing huge monetary funds and resources into AI as a technology in order to compete. Universities are setting up data science degrees, machine learning degrees, deep learning masters, etc. And every major company on the planet today is looking at how they can contribute to R&D in this space and how they can leverage this technology in their own operations. So there is a broad public interest, and what that does is that you get a lot of resources into the space, plus a lot of talented and smart people start focusing on the problems that relate to developing more powerful AI. The last thing that I want to mention now in this preface, before we dive into some application areas, is that when we're talking about artificial intelligence today, then we actually mean narrow AI, or what is also being called weak AI. So artificial intelligence today is really good at solving specific tasks that are almost routines, repetitive tasks where you can get some pattern. One example is that today it's very easy to train an AI algorithm that can play chess on a regular chessboard. However, if we increase the chessboard to be 20 by 20 squares instead, and we added a couple of new pieces to it, we couldn't take the same AI algorithm that was trained on the original chessboard and let it play on the new board with the new rules and new circumstances, because it wouldn't be able to generalize. So it works well in a limited context, and it's good at like automating routine jobs. However, what many people are claiming to be the holy grail of this technology is when we can develop artificial general intelligence. So that would be an AI algorithm that can take from previous experience, that they, for example, know how to play chess, and then they can generalize basically to any chessboard, or it can even play other type of board games by knowing the rules of one and how to play one. That's almost how we humans generalize our own knowledge and expertise. Some people are also claiming that we will reach the state of superintelligence, or the point in time that is being called the singularity. Now, this would be when we have machines, systems, or algorithms and models that would vastly exceed the cognitive ability of humans in every domain of interest. So basically that computers will be smarter than us in all areas where we could be smart. And during that point in time that we call the singularity, these machines would also become self-improving. So they would basically rewrite their own source code and upgrade themselves. And this is kind of like the Terminator scenario, or a sci-fi scenario still. But many renowned like researchers and professors in the space, like Nick Bostrom at Oxford or Max Tegmark at MIT, they are discussing this. But I see it more as a sci-fi scenario that we might reach in a couple of decades. And then it's possible that we will merge with the machines in order to create superhumans or something like that. But now we're going to make it more tangible, and we're going to dive in to 3 application areas for AI. So I'm not going to cover deep reinforcement learning. If you're interested in that, I would suggest that you actually apply to Plaksha, and we will cover that in the data science course that I'm hosting at Plaksha in depth. But today I'm going to do an overview of computer vision, generative models, and natural language processing. So first of all, when it comes to computer vision, this is many times called the genesis application of the deep learning revolution, because this was the academic field and the application area where deep learning models like neural networks became really useful first. So only as an example, it used to be very difficult to solve the problem that you can see on the slide here. Now, the problem that we have in front of us is that we have a data repository with images. An image can either contain a cat or a dog, and we would like to create a binary classification model that can classify an input image either as a cat image or a dog image. So very, very simple problem description. However, historically, this has been a very hard problem to solve because computers and models and algorithms, they haven't performed well when it comes to analyzing visual content, and that can be either images or videos. So it used to be the case that the best computer vision practitioners and researchers in the world, they would hand construct feature maps. So they would basically come up with rules and tell the model how to make decisions depending on the patterns that were being picked up from the input image. Now, an input image contains pixels. You have 3 color channels, red, green, and blue, and then you have the pixels that outlines the object. So before the deep learning revolution, then the best computer vision practitioners would create feature maps that, for example, picked up edges in images, geometric patterns, color patterns, and maps. And they would need to actually think about all of those feature maps before they actually made a decision on what the image contained. A really good performance historically on this task was 75 to 80% of classifying images as cats or dogs. Now, this is the first example that you give in a deep learning course in computer vision, and it's very easy to get an accuracy that is above 95% by leveraging and utilizing a deep learning model. So instead of hand constructing the feature maps and tweaking the parameters in your model, you will train a deep neural network, and you can see a schematic overview of a neural network here on the slide. So you basically have many parameters. Many times it's millions, sometimes it can even be billions of model parameters that all can be adjusted end to end when you train the network. So you don't have to provide it with parameter weights. Instead, you provide it with labeled images of cats and dogs, and then you constantly evaluate its performance and let it optimize its weights or parameters end to end when it's being trained. This was remarkable and a huge revolution for the computer vision space. So if we take an example, that is the Imagenet Competition. So this used to be the largest computer vision and image recognition competition in the world. Basically, it's a competition where you have a data set that consists of 1.5 million images, and every image in this data set belongs to 1 out of 1,000 object categories. And before the introduction of deep learning models in this competition, the top 5 error rate was 28% in 2010 and 26% in 2011. Then something remarkable happened in 2012. So this was the first year a neural network model or a convolutional neural network was used in order to win this competition. And as you can see, the error rate dropped by 10 percentage points. The people who did traditional computer vision couldn't believe those results. Ever since then, a deep learning model has been used in order to win this competition. And as you can see, the graph here ends at 2017 when the error rate was 2.25% for the top 5 error. Today, that's much less than 1%. The only reason why we don't have more numbers on the graph is because the competition is not running anymore, because it's very easy to actually overfit your models to this data set. Now, you might wonder, well, it seems to be the case that these models are very high performing. What is the human baseline on this task? So if we took a human and we let that human pick random images from this data set of 1.5 million images, and then the human needed to classify the image as being 1 out of 1,000 categories, where we actually have a human benchmark, because a poor graduate student at Stanford University had to spend many late nights and evenings, weekends, learning the 1,000 object categories by heart, and also practicing doing this. So after a couple of weeks, that graduate student, and he's probably a smart person, a graduate student at Stanford, was put up to the challenge of classifying a couple of thousand of these images so that we got a statistically correct baseline for the human performance. And his error rate was 5%. So one can even say that for this limited, well-defined context of computer vision, then deep learning models today are performing much better than humans and can make decisions in split seconds and make decisions 24/7 around the clock. There are many more application areas of computer vision. So as I said, we can do classification, taking an image and saying what kind of object we have in that image. We can do classification plus localization. So we can say within a bounding box where we're going to have the actual object. We can do object detection, that is classifying many objects in one image. So we can say here is a dog, here is a duck, here we have 2 cats, and instance segmentation, and that is saying exactly what pixels belongs to what object in an image. You can see a video here of an object detection algorithm running on a video in real time from Times Square in New York. And here you can see that it picks up people in bounding boxes, trucks, traffic lights, cars, etc. The performance of these algorithms are stellar today. And it only took a couple of hours to translate an algorithm like this, for example, to an application area so that we could combat the spread of the coronavirus early on in the pandemic. So here you can see an object detection algorithm that draws bounding boxes around people and also identifies them. Then when people are interacting with one another in too close proximity, the bounding box turns red, and that means that you might have been exposed to actually transmitting the disease between people. And then if someone actually catches the virus, you can inform all other people that they might have been exposed. Another fascinating thing that we can do with computer vision today is that we can feed in input images, like the ones that you can see here on the top right corner of the slide. And then we can do image captioning. So for example, when you feed in this image here, the algorithm would put out what is happening in the image. So here you can see the subtitle or the caption would be "Man in black shirt is playing a guitar." Same thing for like the construction worker and the people playing with kids' toys. So a lot of cool things powering many different applications. And this is also what has led to the great progress that we have seen for autonomous vehicles and self-driving cars. So in the image here, you can see a Tesla that is leaving a residential area and then driving out on a freeway. And the driver is not even touching the steering wheel. A Tesla today is equipped with 8 cameras. So to get a 360 view of what is happening around the car. And that visual input is the main factor that the Tesla is using in order to make decisions around how to turn and how to act in traffic. And we have reached level 3 autonomy today, which means that a Tesla can drive itself for many common circumstances. Outlier events are still a little bit shaky, but I think we will get there in a couple of years. So that was computer vision. Now, if we jump into the second application area that I wanted to cover, then I want to talk about generative models, and especially visual generative models. So in this way, computers can be creators, it can be artists, and it can be fraudsters. The first example of an output of a generative model, or specifically from a generative adversarial network, is the one that you can see on the slide here to the right. So this is an image of a woman. What is remarkable about this image is that this woman has never walked Earth. She has never been born, but she has been generated by a computer algorithm and by an AI model, and specifically a GAN that is called a style GAN. If you go to the website thispersondoesnotexist.com, then every time that you update this website, you will get a new image of a person that has been generated by an algorithm and a model. And these people have never existed. I would say that it's very hard for the human eye to distinguish these images and these pictures from images and pictures of actual humans. And the specific model running here in my browser, I think that has like 18 months or 2 years on its neck. So I mean, it's kind of old. It's even more state of the art today if you have models that is not running in the browser. If you want to explore more cool generative models, you can go to this x.doesnotexist.com. And then you can, for example, have GANs that are generating cats that never have existed. Or you can generate Airbnb listings that never have been posted. So both generating the text, generating the images for the listing, and then every time that you update it, you will get a new host that has been generated, new images from the actual rental, etc. One of my favorite ones, because I have many entrepreneurial students, is this startup.doesnotexist.com. So if you go here, you will get the title of a startup, a logo for it. You will get some sort of like tagline or slogan combining unexpected services to create awesomeness, kind of vague. You will get a team. You will get some like features of the startup. And if you update it, then you will get another startup name. Let me see what, here we go. Hyperent, make it a service. You will get some clients, maybe a testimonial, even like billing tiers, etc. So if you would like to get some inspiration around a business to start, you can go and visit that site. Some smart entrepreneurial French people actually monetize this opportunity early on when this technology became available. So they took one of these generative models and they trained it on paintings from open source data sets from museums. In that way, they had a model that could produce output paintings in the style of specific masters or painters from history. They took one of these portraits and sold it in an auction at Christie's for $432,000. None of the money went to the researcher at Stanford, Robbie Barat, who had written the code, because all of it was open sourced. So the French entrepreneurs were the ones to see gains from this. Another thing that generative models allows us to do is to create so-called deepfakes. So you might have heard about deepfakes now over the years. The one of Obama here is a video of Obama saying things in Obama's voice. It's a video of Obama, but it's things that he has never said himself. I think that's from 2018 or 2017. A year back or a year and a half back, people even showed that you could create generative output video by only showing one picture to an algorithm. So here you can see the Mona Lisa coming alive. And if you want to see state-of-the-art deepfakes today, you can Google deepfake Tom Cruise. You can see a GIF from that video here. And I can promise you that it's almost impossible to distinguish the deepfake version of Tom Cruise from the actual actor Tom Cruise. Now, this creates a lot of challenges for society, because in our court systems, for example, many times we use images and video as evidence when we are going to determine the outcome of a court case. Because today it's very easy to create deepfakes only by scraping, for example, a person's Instagram images or Facebook images. Then you can create videos of that person doing things that he or she has never done. And maybe that could mislead people into thinking that someone has done something that they haven't done. Also, if you think about the fact that we can take political figures, we can make them say things that they haven't said, and that could even lead to catastrophic outcomes like starting a war or similar things. This is very important for every citizen to know that information can be altered in this way. And yeah, if you want to see how scary it can be, definitely go ahead and Google deepfake Tom Cruise. I promise you that that is, even I get like vertigo looking at that. Some other companies are finding very creative or innovative business models using visual generative models. Here you can see a tech company out of China that was acquired by Tencent a year back. So Tencent is the big like Chinese tech giant. This company found a way of in real time inserting product placements into movies and TV series. So here is a company called Lurking Coffee or Lucking Coffee. And you can see their products being inserted into scenes, billboards. You can see actual like a coffee cup getting rebranded in real time. I think that this kind of targeting with generative models is going to become very prevalent. So only imagine if you're Googling for a Lacoste like piqué or a polo shirt before lunch one day, then I can almost promise you that if you're watching Netflix in the evening, then your favorite characters in the movie or the TV series is gonna wear a Lacoste polo shirt so that you get more intrigued into buying it. And that's gonna be much more relevant and directed marketing than what we have today. Now, before we enter the Q&A session, the last application area that I wanna cover is natural language processing. And I would call this the current renaissance period of AI today and the renaissance field. The most has happened in NLP in the past like 2 or 3 years out of any field in AI, at least according to the perspective that I have. And that is because of the introduction of attention mechanisms and transformer models. So when we talk about natural language processing or NLP, then we mean tasks like the ones that I've outlined on this slide here. It could be the ability of a computer to be able to take some speech and translate that into text, or take some text and then translate that into speech. It can be machine translation between languages. It can be to summarize corpora or big text documents. Also to do sentiment analysis, to say if some written text is positive in its sentiment or negative. To do text generation, so if you provide some inputs to an algorithm, it will complete that input, or maybe write an article for you or an email. And it can also be question answering. So if you have a question, can a model or an algorithm answer that question for you? Only if we go 10 or 15 years back, it was pure science fiction that we would be able to speak to our devices. Just as it was science fiction that a car would drive itself, at least I didn't think that a computer would be able to understand me almost perfectly when it comes to my intent of common tasks and stuff. But today, on a daily basis, at least I speak to Alexa devices and Google Home devices. So we have come a long way on many frontiers in NLP. Also, if we look at text generation, then in 2019, OpenAI in San Francisco, so that is one of the most advanced AI research labs in the world and nonprofits in the world. I think there are semi for profit now, but at least they started as a nonprofit. OpenAI released a very powerful general natural language processing model called GPT-2. That model was interviewed by the news magazine, The Economist, and you can see that interview. It's stretched actually for 3 pages in the magazine. And here you can see the start of the interview. So the journalists are asking the questions in italic, and then the algorithm is providing the answers underneath. So it starts with greetings, GPT-2. Have you done an interview before? And then the algorithm answers, I'm not going to lie, I did not come prepared. And then it even adds a laughter. Now, if you actually read this interview for the full 3 pages, what becomes obvious is that many times this algorithm is more eloquent and better at expressing itself than most humans. Now, I thought that was scary in like 2019, 2020 when I saw that, because it was such a huge leap forward. It used to be the case that NLP algorithms were a little bit non-relevant and random in its output, but all of a sudden it was kind of coherent. I took this model and experimented with it a little bit before this session, now today. So as an input to the algorithm, only to show its power and how relevant it can be, I provided, today Alexander is hosting a session on AI, machine learning, and deep learning applications for Plaksha University in India, the session. That was the only input that I gave the model. Then it completed this input and started generating more text that would be relevant according to my first input, like half paragraph or only 1 sentence. So then the algorithm says, the session will explore the role of machine learning in education and provide an overview of open source machine learning software. He will explain, and bear in mind, it's picking up he, so it knows that Alexander is explaining something. He will explain how data science, machine learning, and big data analytics can help improve the efficiency and effectiveness of higher education. This session will cover the latest state-of-the-art technology, computer vision, and natural language processing algorithms. That is crazy that it's like picking out those 2 because I've talked about them. Predictive analytics, business intelligence, etc., etc. This is remarkable, this kind of performance, especially if you were around and saw like recurrent neural networks and LSTMs in 2016 and 2017 and their performance. However, GPT-2 was the earlier paradigm. Less than a year ago, OpenAI introduced GPT-3. So that is the new model version that is state-of-the-art in natural language processing. This model has 175 billion model parameters. And you can see kind of the trend when it comes to state-of-the-art NLP models. So here we have GPT-2, it had 1.5 billion model parameters. And then GPT-3 has 175 billion. This model has been trained on over 300 billion tokens. That means over 300 billion unique words. And only to train this model once has an estimated lower bound training cost of around $5 million. So it's not that a research group at a university could train this model if they didn't get a significant grant. But now it's almost exclusive to the big like tech companies in the world to be able to do this. So the data set that this model has been trained on is basically all of the high quality textual data that you can find on the internet today. So it's all of Wikipedia, it's relevant threads from Reddit, it's Twitter, it's a mix of like web crawl, etc. And I heard in an interview with the CEO from OpenAI, Sam Altman, he claimed that the bottleneck for these models now are not the like model parameters and how to train it, but it's actually getting more relevant textual information and data onto the internet so that it can pick up even more patterns. So we don't have enough information on the internet today in order for these models to become very powerful, basically. Now, what is remarkable about this NLP model is that I would almost like to claim that it's the first instance that I have seen that could be portrayed as a little bit of AGI or artificial general intelligence, because this model is able to handle so many different application areas. For example, there's a company in San Francisco called Copy.ai. What it can do for you is that it can create automatic copywriting for your company or for your product, for your project. So as an example, if you put in a product name that is Dunder Mifflin and then short product description, premium paper for small businesses. If you press generate here, then Copy.ai will produce for you outputs of copywriting that you can use in your marketing, on your website, and it can produce so many different outputs, and you can choose the one that fits your purposes best. The results with this product can be amazing. So what it can do for you is that, for example, it can create digital ad copy, social media content, website copy, sales copy, blog content that is actually relevant. There was one blog writer who used GPT-3 in order to create a productivity blog that ended up being ranked #1 on Hacker News. So that was only output from GPT-3, and all of a sudden, people thought that was the best productivity blog on the internet. So that speaks to the power of this model. Another example that I'm going to show you is that you can use GPT-3 in order to train it to be able to take pure like English language inputs, like in the example here. So here we write in pure English, add button that says add $3 and a button that says withdraw $5, then show my balance. What this will do then is that it will generate a React web application that has this functionality that you have described in pure English. So here you can see the rendered web application to the right, and it actually works. To the left, you can see the source code of the application, and the source code has been generated by the GPT-3 model. All of this is very cool. I'm not going to go through all the examples here, but you can do automatic email generation. You can write legal paragraphs. You can even do like code generation for data science tasks. So you can build a neural network by only inputting in plain English how you want it to work. And you can create a search engine for it that even could have some better capabilities than Google at times. Now, the true revolution with GPT-3 is that you don't need a lot of data in order for it to work really well. So GPT-3 works great for zero-shot learning. That means that you have a task that it should perform, for example, translating from English to Hindu, and you can describe that task for the GPT-3 model, and you don't have to provide it with any labeled data set. It's not supervised machine learning, but it can pick up the pattern all by itself. It's also really good at one-shot learning. That means providing one example of a translation from English to Hindu. And then few-shot learning. You only have 10 examples or 20 examples of what you would like to do. And I have one example here on the slide. So if you only provide 10 examples of actual descriptions of HTML content on a website, then you can train that. So you would show the actual output and the code that would be generated. For example, if you wrote a button that looks like a watermelon, And then all of a sudden you can write a button that looks like a lemon, or you can write a nav bar that looks like a spaceship, and potentially this algorithm would know how to code it up for you, so you don't have to be a coder yourself. I think this type of technology and innovation is going to power so many use cases now moving into the future, and it will disrupt so many traditional occupations. Only if we take lawyers as one example, it used to be the case that the legal system relies on legal clauses that are kind of opaque for laymen. So people who are not legal professionals would have a very hard time deciphering what it says in this legal clause that you can see on the slide here in black. However, people have used GPT-3 in order to train it on translating very complicated legal clauses into plain English. So if you see the plain English output from GPT-3 is, if the startup is wound up, so that means that you close the startup, the Series A investors will be paid back at least what they had invested, and they will also share any leftover assets with ordinary shareholders. I can actually understand that, but I wouldn't be able to understand what was said here at the top. So with generative algorithms specifically today, I think that we will be able to get help writing our emails. Movie script writers will be able to get help writing their movie scripts. I have even seen high school students use these generative NLP models in order to turn in full essays and getting an A+ grade on that assignment. I think these are going to be very powerful tools. They are not going to be completely autonomous and work by themselves, but it's going to be hybrid systems where our human capabilities are going to be augmented by the capabilities of these AI systems, models, and algorithms. But I'm very, very hopeful that all of these technologies are going to make life better for humans in most cases. And we also need to be aware of the technological advancements so that we can mitigate risks, for example, around deepfakes that I mentioned, or other things. With that, it was my great pleasure to present this presentation for you about state-of-the-art AI applications. If you have any follow-up questions after the session, feel free to reach out over email or connect with me on LinkedIn. I don't know, ping me over Twitter or DM me if you want to do that. But thank you so much for listening. And now we can open up for questions.
Great. Thank you for the session, Alex. As usual, it was wonderful listening to you. And even though the content was something that I had gone through before, it was still something very new. There were so many pieces of content that were new to me. And I'm sure it was lovely for the other attendees as well. We have a ton of questions here, and we have approximately 5 minutes. So first of all, I would like to ask you, would you be okay extending the session by 5 minutes?
Absolutely.
Or do we have? Oh, perfect. Okay. Then I'll just read out the questions as and when they come in. First, this question is by Pranav. He asks, can we say that the biggest barriers in today's AI technology is the lack of robustness, biased models, and unavailability of enough clean data? If not, do you foresee any bigger challenges?
No, but data quality is definitely one of the major barriers for creating high performant AI systems today. So that you don't have the right data, or if you have irrelevant data, if you have biased data, and even barriers like legal frameworks that are being introduced now in different regions all over the world, especially in the European Union, like GDPR and the first regulations around AI. I think all of this is very important so that we have a safe rollout of the technology. And I also think we need to make them more like trustworthy and ethical. We need to think about transparency, explainability, interpretability, and all of those are kind of nascent research areas. But maybe some of the most important things we need to think about now when we're going to release like self-driving cars and maybe have robots that are going to be in our city centers, and very important like algorithms making decisions for, I mean, even like the defense of a country and the military, or court cases, helping the police, etc. We need to be very, very careful that we don't create an unjust society, or that we don't introduce algorithms and models that would work against factors like diversity or fairness, inclusion, etc.
Next question is by Gaurav. He asks, as we all know that we are in a data-driven world and everything is related to data directly or indirectly, do you think that there arises a question that we as humans are biased to algorithms? For example, if an autonomous car is met with an accident, we simply form a judgment or a bias towards the algorithm that it is being developed in a wrong way. And this bias magnifies when decisions are inconsequential. Sorry, when decisions are more consequential.
100%. So you can only see that in the way that we evaluate, for example, the performance of Teslas today. So every time a Tesla gets into a lethal accident, it becomes headlines almost all over the world. And we blame the AI algorithm, but we never blame like human drivers when they get into lethal accidents. Maybe that's in the local paper that someone was in an accident at most. I think the best way of looking at this is also to analyze the data that we have at hand and get some statistics from that. So to evaluate the performance of self-driving vehicles or autonomous vehicles, if we stick to that example, we need to check the performance of self-driving vehicles and compare that to the human baseline. And if it's an order of magnitude more safe to be in a self-driving car, even though it gets into some accidents, of course, we're going to adopt that technology and let that out on the roads. I've been at Plaksha in India, and only to be in traffic in Delhi can be a little bit scary, as many of you know, I think. So to have self-driving cars that would not take emotional decisions in situations like that, I think that could be valuable. And still have hybrid systems. So only having an AI system that the human driver can override, but that would help you in situations where it might be hard to see that someone is gonna jump out on the road because you don't have that like 360-degree view as a Tesla does. I'm truly a believer in like hybrid systems for medical AI when we start to see the rollout for like doctors and X-ray physicians, etc., in order to do evaluations. But the doctor should have the final say, but the AI algorithm can actually support that decision.
The next question is by Arvind. He asks, given that computers can identify different objects with a greater accuracy than humans, why do we still rely on CAPTCHA to verify if it's a human or a robot?
Because when you input the labels for a CAPTCHA algorithm, you're actually improving Google's computer vision algorithms. So it's a way for them to aggregate a larger repository of label data. You become an annotator and you should send an invoice to Google because that's valuable work for them.
I remember this was something that came up in the class as well, and the answer is really fun, so I wanted you to say it again. Next question is a Saikat. He asks, as an aspiring researcher in AI, how do I build my portfolio for real world projects? He says most Kaggle competitions are not attuned to real world data or are very small, and we do not have large computing power. So, I mean, Google Colab is the biggest computing resource that we have, and that doesn't offer a lot. So any suggestions?
You can actually do a lot with Google Colab today as well. I wouldn't say that that is a major constraint for most problems. It depends on if you want to train a model from scratch, and many times that is not the case. When you want to solve a real world problem, you should try to bootstrap whatever state-of-the-art solution you can get that is either off the shelf or a paid like API service from one of the big cloud providers. Now, in order to get the real world experience and to become a researcher or a real world practitioner, I would recommend that you try to get an internship at a company that is working in this space, because just as the person now asking the question said, solving Kaggle competitions that gets you up to a certain level, I think that can be valuable to some extent. But actually getting a data problem where there is no solution, or thousands of people have not looked at the problem before, and then going through the journey of exploring that problem and coming up with hypotheses on how to solve it, etc. That's when you get the best real world experience. And internships are good. And if you really want to be, like, have that on your resume, even having an unpaid internship would be something that could be valuable. But it's a learning journey also. So, I mean, only to be in Plaksha, that is great as well, because then you have a capstone project that is real world. We have some real world projects in the project and applied data science course that I'm hosting. So we try to mimic how the real world actually works.
The next question is by Sai Venkat. He asks, is there any work being done on recognizing deepfakes using AI itself? If yes, where do you think this game of catch-up would lead to?
So there is definitely a game of catch-up, and there are many researchers creating systems that can spot and identify outputs from deepfakes, and then the deepfakes algorithms gets improved. I think you can draw the analog to cybersecurity. So only if you look at cybersecurity and like computer viruses or malware for computers, that is also a game of catch up, where you have Microsoft, Apple, or even like firewall software retailers. They keep on updating their system so that they should be secure, but then still there will be attack vectors that they haven't covered, so that people actually can create a Trojan horse or whatever. We're gonna see the same thing for deepfakes. I'm a true believer in crypto systems and blockchain technology to verify information, and I hope that we can launch almost like verification systems online, so that we can see the source of certain information coming from specific people, and it has like a digital hashing signature associated with it, so that we can verify that it's not a deepfake from a malicious actor. But we will see. That's a couple of years down the line in a completely different lecture.
Yeah, we'll just take a couple of more questions. Subodh asks, given the potency of AI, it will definitely reduce the human resource in the traditional fields. Do you think that will lead to a shortage of jobs?
No. So every technological shift that I outlined in the beginning of the presentation, going back to the Industrial Revolution, the robotization of production lines, etc., people have always claimed, or kind of like researchers, essayists, experts, they have said that it's going to lead to massive job loss. But we have actually created more jobs for humanity net. I think that's going to be the case now as well. However, we might not need to do a lot of boring work, repetitive work, and work that can be automated. I hope that robots can do that for us. And also that we might be able to reduce our working hours, and maybe that we are going to concentrate on other values in life. So when we say work, maybe that is like communal teaching, socializing, sharing ideas, working in tandem with the computers. But that's also me much more like speculating. I think short term, it's not going to lead to huge like job loss or anything, because we will invent new jobs and people will need to manage these systems, and it's still going to be like humans in the loop for all of it.
Right. And last question before we call it a day. Sai Venkat says he was fortunate enough to attend a lecture by Geoffrey Hinton, and there was a discussion around how the AI world is focusing more on pursuing higher level AGI and less on deploying existing AGI to solve problems. How do you think we can bridge this gap?
So was basically the takeaway from Geoffrey Hinton that we are concentrating on AGI and more general intelligence, and we're not concentrating on what we have in front of us today that we could apply to solve problems. Did I understand the question correctly?
Yeah, right. I mean,
I actually do think that we see the deployment of AI systems today. I mean, this is a learning journey for many companies, professional actors, and people in this space. So there has been many like failures and proof of concepts that haven't come to fruition, that haven't led to a return of investment for the companies that are doing these bets. The main reason for it is that the technology right now is maturing and the field is very nascent. So only the fact that occupations like machine learning, ops, or data engineering, all of these things are kind of new, and we're creating a new infrastructure for how you handle data, how you share data in an organization, how you set up data quality indicators, etc., etc. And when we have that more in place, and I mean, I can already see the progress is almost exponential when it comes to that as well. You're going to see every company leveraging this. And we have many industry agnostic applications of artificial intelligence, for example, to automate customer support, looking at churn prediction or retention strategies, targeting or marketing, etc. That's relevant for basically every company. People are creating solutions so that you can use your data in order to do it in your specific context. And every company is becoming more data-driven. I think that every company needs to think about data-driven business models and how to leverage emerging technologies in order to create a competitive advantage.
Thank you, Alex. There are a ton of more questions, and I'm sure you'll be receiving a lot of mails. To all of the attendees out there whose questions weren't answered for the lack of time, and to those who would like to pose any other questions, the details of Alex are right in front of your screen. Please do reach out to him, and I'm sure it would be worth your while. Before we close it for today, there are a couple of announcements. There's another session tomorrow, which is on how leaders in data science are changing the world for the better, with Dr. Ikhlaq Sidhu, who is the faculty director and chief scientist at UC Berkeley, and Vineet Gupta, who is the founder and trustee of Plaksha and the co-founder and MD of Jambori Education, at 8:30 p.m. IST tomorrow. Second, the round 3 application deadline for Plaksha Tech Leaders Fellowship closes on May 23. So we have 1 week to go. So in case you're interested in this program, do check out the website and feel free to call in case of any confusions or doubts, and we will be more than happy to help you with that. With that, I would like to call it a day, and I'd like to thank you once more, Alex. There's a reason why there's so many members on this call of the current cohort as well as of the previous cohort, because we can never get enough of you. And no matter how much, how many sessions Plaksha try to introduce of yours into the course, it's always less. With this, we hope to leave you in good health and stay safe. And I'm sure there are many more sessions and that you will be enlightening us with. And thank you so much, Alex, and have a good evening.
No, thank you so much for moderating, Ankit, and thank you everyone for listening. This is my great pleasure, and I hope to see some of you at Plaksha in the fall now this year, because hopefully traveling will be possible and all of that. So have a wonderful evening. Thank you for listening, and I look forward to future interactions.
Thank you. One last thing, for all of those who have requested slides, the recording of this video of this session would be available on Facebook. So you can check out the recording there, and as well as see the slides there. Thank you so much. Have a nice day. Bye-bye.
Bye for now.